For methodology, predictive analysis uses historical and real-time data to forecast future outcomes. It identifies patterns and trends to answer what is likely to happen next. This typically involves statistical modeling, time series forecasting, and machine learning classification of regression models. For technologies, it frequently uses tools like machine learning platforms like Python, TensorFlow, also statistical software like SAS, and it uses data visualization dashboards like Power BI for trend interpretation. And lastly, applications. Analytics is used when businesses need to anticipate behavior, like demand forecasting in retail, customer churn prediction in telecom, or risk scoring in finance. For its methodology, prescriptive analytics goes a step further by recommending specific actions. It answers what should we do, using optimization techniques, simulation models, and decision rules to evaluate different choices and their expected outcomes. It relies on certain technologies like optimization engines, simulation tools like the Monte Carlo simulation, and decision support platforms that integrate predictive outputs with business rules. Some of the applications that it uses, uh, inventory things like inventory replenishment decisions based on forecasted demand and storage costs, route optimization in logistics to minimize fuel costs and delivery time, and dynamic pricing models that adjust prices based on demand predictions. Predictive analytics uses data to anticipate future outcomes. It analyzes historical trends and current patterns to forecast what is likely to occur. This helps decision makers plan, prepare, and reduce uncertainty, but it does not directly tell them which specific action to take. In comparison, prescriptive analytics uses both the predictions and real time data to determine the best course of action. It evaluates different choices and their possible outcomes, and it then recommends or automates decisions that align with organizational goals. So predictive analytics uses statistical software like R, SAS, SPSS for regression, forecasting, and pattern detection. It also uses machine learning platforms like Python or TensorFlow for classification and predictive modeling. And lastly, it also uses data visualization dashboards like Tableau or Power BI to display trends and forecast results clearly. On the other hand, prescriptive analytics uses optimization and decision engines like Gurobi and IBM Cplex to determine the best solution among many options. It also uses simulation tools like AnyLogic, Arena, and Monte Carlo simulation to test different scenarios and estimate outcomes. Lastly, it also uses business rules and decision automation platforms like IBM Decision Optimization and SAP Integrated Business Planning to embed recommendations into workflows. Predictive analytics can be effective for customer churn forecasting. A telecom company uses predictive models to identify which customers are likely to cancel service. The output helps managers plan retention campaigns. It can also be helpful for sales and demand forecasting when a retail brand predicts seasonal demand to plan inventory levels and avoid stockouts. Lastly, it can be good for credit risk scoring. For example, a bank can evaluate the likelihood that a borrower will default to inform loan approval decisions. Prescriptive analytics can be more effective for inventory optimization. A grocery chain uses prescriptive models to decide exactly how much stock to order for each location while minimizing waste and storage costs. It can also be effective for delivery route optimization, where logistics companies can determine the most efficient delivery routes to reduce fuel and time while meeting service deadlines. And it can be effective for dynamic pricing. An airline can adjust ticket prices in real time based on demand forecasts, seat availability, and competitor pricing.